So actually, uh, using Python or using any type of tool to automate and make the process of analytics more easier for you and for anyone else. Actually, it starts from pinpointing the weaknesses in your workflow or in your existing workflow. Because if you do not diagnose the weaknesses that you have in your existing workflow, then you cannot go ahead and improve it. So I will give you an example. We have lots of oil and gas engineers. So the petroleum engineers, they basically do, for example, data management. So they manage data from the field, from the wells. So basically, they do back allocation, and mostly they do this using Excel. So by pinpointing where are the weaknesses or where your workflow gets bottleneck or it gets slower and basically takes lots of time from your hand, then those are going to be the starting points where you can start utilizing Python to make everything faster, more reliable, and easily producible in the future. So this is one of the things that you can do. What was the next question? Actually, especially this thing that worries lots of people's professionals. To be more precise, is professionals they don't have like enough time or they don't have much time to spare uh, for these types of things. So what we have came up with in this training is actually it's a unique approach of training Python or teaching people how to use Python. So the thing that we do is like this. Number one, so the total sessions we have is 16 sessions. Okay, so out of these 16 sessions, we only dedicate 2 sessions for the basics. So these are going to be the bare minimum basics you need. So this equates to 4 hours. Once you get like the hold on the basics and understand what's happening and what's basically being used under the hood in Python, then we can start by utilizing a different approach of training, which is a project-based training. So what we do usually is we will set for each day, we will set 1 or 2 targets depending on the size of this project that we do. So let's say, for example, we set 2 targets for the day. So the target for the day, for example, let's say we want to do some type of forecasting or some type of water oil ratio analysis. So what we do is we make sure that we understand the technical side of it, and then we will try to build a solution around that. And anything that's related to that solution, Python basics, plotting, calculation, output, everything is going to be explained around that project. So basically what we do is we take a project and then we teach the people how to uh, basically figure their way around as inputs and outputs of this particular project. So this is basically what usually happens in those 16 sessions or these full 8 weeks of training. So it's always going to be a project-based thing. So you're not going to find like some boring YouTube videos like they are basically explaining what a for loop is or what a table is. What we do is actually we set a problem and then we try to solve that problem by utilizing Python. So this is basically what we do. And of course, it requires zero understanding of Python because everything that we do, we start from scratch. We build our way up. Plus, we make sure that everyone is on the same page. Plus, we do regular surveys on these. We make sure that people are understanding this before we move to the next critical topics. So regarding the production and the reservoir, we have actually lots and lots and lots of topics. So let me show you like the latest version of our workbook guide that we usually share with our participants. So this is an updated version. This is not the version that you usually find online. By the way, we already have a free version of this uploaded online, but it's actually this is like 15% more examples. Plus, we're going to add more examples to this. And this is a list of the examples that we have. It's something close to 50 examples. So regarding the reservoir engineering and the production engineering, which represents like 40% of the training, you will have like 20 examples to go through, and most of these are related to the engineering, production optimization, ESP dashboarding, and whatnot. Plus, we have a new section that has been recently added, which is geological and spatial mapping. This is a new section we have just added this year. So basically, this section for people who goes through this training, they will get like this full section. So I basically teach them how to create different maps using 6 different methods. So these methods are the cubic spline, the fast interpolation, the machine learning based models where you use machine learning and convert those into actual maps. So this is what it looks like. We also teach them how to use the cryogenic property distribution, where you by the way, this one you will find usually in Petrel, but you can also do this in Python. Plus, we teach them how to also connect this with time, where you have like different times, different wells are being added, so different properties are being captured. So you will get different property distribution, or basically different realization at different times. Okay, so yeah. Plus, we also teach them how to create cross sections. So these are all the new examples. Plus, by the way, we have few more examples that are already added. For example, dashboarding and advanced well log handling. So all of these things are usually covered in the reservoir engineering and production engineering aspect. Plus, we have like lots more examples related to operations and drilling and whatnot. Much, Nikhil, and first of all, I would like to thank everyone who has dedicated time and made sure that his time is allocated to attend these 3 sessions. If you have not attended any of the previous sessions, please do not be worried, because the recording will be uploaded by the end of the day, and you will be having the access to all of these recordings. Now, if I do my task correctly, in today, I'm going to show you 2 examples. Those examples or these many projects that we do are going to be powerful projects. They will resonate very, very fast, and you will be getting first-hand exposure on how Python can be used for production monitoring and production optimization. Okay, so what you see in front of you is a software called GAP. So a GAP software, it's a very infamous software in the oil and gas industry. It's used for production network simulation, but it does not have to be always wells. It can be injection wells, production wells, pipelines, nodes, different types of components, facilities, pumps, equipments, reservoirs, basically anything that you can think of that you can find usually in oil and gas field, you will find in this software. So the example that I'm about to show you, I'm not going to teach you how these things are created, because creating these usually have like a good background on production optimization in order to create these types of network. These type of things or these types of project, actually they are in 2 phases. Phase number 1 is to create the network and get elementary results with it. And phase number 2, which is the longest phase of them, which is the maintenance of this model. And in this model, what I am presenting is it's around like 16 wells, but I have seen models more than 1,000 wells. So the more the wells you have, the more the daunting the task will be. So that's why whenever you have like lots number of wells, it's important to start using Python to manage these wells. So let me show you an example. Okay, so if we go ahead and, for example, by the way, those upward looking arrows, so these green things those are the wells, by the way. So if we double click on any of these wells, you will see that we have multiple inputs. By the way, we have, for example, the input, we have the pressure, we have the, for example, the API, we have the gravity, they have the GOR. But basically, these things usually change per well, depending on the location of the well and how close the well is to the set fluid source, which can be gas or can be water. So these things usually change. Okay, so this is if the well is flowing naturally. But if the well is flowing using gas lift or using ESP, we could have like more parameters that we can tune. Okay, so what usually an engineer will do, okay, so an engineer will be assigned to a set number of wells. For example, let's say our engineer is assigned to like 20 wells. So what he will do, he will go through these wells one by one and then update those, make sure that everything is set correctly, and then it will try to validate this and then pass the model, or basically validate the model and then pass it to the next engineer. Okay, so usually this takes some time, especially if you have like large numbers of let's say assets that are already modeled in this and baked in this. So the main problem with these types of models is not to get the results. The results is something given. You will get the results no matter what the type of the result is, whether it's correct or false. The most important thing is to keep the model updated, keep the model documented, and keep everything current. So this is the most important thing. I will show you in this example how Python can be used in order to automate this process. Okay, so let me show you one thing. I will put this software by side with Spider. Okay, so Spider is the application that I'm using to write Python code. By the way, you can also use something else. Let's try to use Marimo, by the way. So you can use, by the way, you can use anything you want. So let's use Marimo. Marimo is a new generation software that's basically built for Python. It's good looking, it's fast, and basically everyone loves it, by the way. So this is what the Marimo looks like. You have already seen this earlier. Now, the main task will be to start reading those one by one. But before we read those one by one, what is the drill? So the main drill or the main task would be to establish a connection to the software. Okay, so how a connection can be established? These types of softwares usually they know that the let's say the vendor company it's not easily going to fulfill all the features that the user want, so that's why they have something called API or application programmable interfaces, where these interfaces allow you to connect to any portion of the software or any feature of the software and basically create an automation around this. Okay, so we are going to use something called open server. So import open server. And once you import open server, what you can do, you can basically start reading this file or basically creating a connection to it. So let's do server equals to open server. Once you do this, we can establish the connection. So let's say server. Let's run this. There we go. Now the server is connected successfully. So if this connection did not happen, usually what you will get, an error message that it says basically the connection did not happen. So let's say connected successfully. Run this. There we go. Now it's working, meaning that the connection is passing through. So we don't have any issues with that. Now let's move to the next step. How we can start automating this. Before we do any automation or before we show you anything complicated, it's very important to understand how we can read different parts of this software. Okay, so the process is not complex, but it requires some form of understanding of how to basically approach this. Okay, so I will create a new code. So what I'm going to do is, let's say that I want to get all the wells. Okay, so we have, by the way, we have multiple wells. So we need to get all the wells. So it's not good for me to get one by one. So we have to get like all the wells at the same time. Okay, so otherwise we are not doing any good. So we have to get like everything at once. Okay, so let me show you how we can do this, by the way. So number one, I'm going to get the names of the wells. So the name of the well is basically the label of the well. So this is what it is. By the way, this requires a little bit exposure to the software. By the way, this is something that we usually cover in the training, how to do such a thing. So this is the label of the software. So let's do a slight search on these labels. So what we're going to do is we are going to get all the wells. So I'm going to create variables called wells. We will say that server dot get. So we're trying to get something. Now, the thing that we're trying to get is going to be a code that's going to be injected into the software. So it basically does some action. So the software's name is gap. We are going to get data from the production mode. And we are basically looking for all the wells. And let's get the labels for these. Okay. So once we get the wells, let's print off the wells like this, run it. There we go. Now you can see there is a small window that pops up. It says that open server monitor window. So basically what we are doing is this software is basically watching what we are doing. So basically it's aware of we're trying to push something or pull something from the data. These are basically the wells that we have gotten, and of course you can count these wells. So let me show you the full list of the wells. And if you compare those, you will find all of these wells do exist in our, let's say, a repository that we have pulled. Now you can see that you can get like a very clear view of the wells. Okay, so these are the wells. Let's do one more thing. Let's get the pipelines, by the way, because we have lots of pipelines, by the way. So we also need to get those pipelines. So what we are going to do, we are going to say pipes equals to server dot get. So we are getting the pipelines. So the command for this is going to be same thing for the production mode. And we are basically looking for the pipes, by the way. And we can get anything in the pipe we want. For example, we can get the name, we can get the correlation type, we can get the gravity coefficient, we can get other inputs like the surrounding temperature. By the way, if you manage these models properly, you should even also change the seasonally. So the surrounding temperature should be changed seasonally. So let me show you how we can get the surrounding temperature. So it's temperatures. It's called temperature surrounding. So let's go ahead and get that. So temperature surrounding. So once we get that, we can also print these up so you can see what's out there. So pipes, run this. It says that variable name it was not found. Okay, so this means that we're not typing the variable name correctly. So actually we are missing a P, so that's why it's not working. So let's try the P. There we go. Now these are the surrounding temperatures. Okay, so all these pipes, they have the surrounding temperature of 50. And let's say that you have, let's say, more than 500 small pipeline segments. If you want to update these, what are you going to do whenever the seasons start to change or whenever the temperatures start to shift in the weather? Are you going to click those one by one and update those? Well, the answer for this is going to be no. This is not a practical thing. What we can do is we can use Python or utilize Python to push those updates. So let me show you. I will be assuming that the weather temperature nowadays equals to 80 Fahrenheit. Okay, so this is the weather temperature. I will be pushing this weather temperature to the pipeline. So what I'm going to say is server dot set. I'm going to set the property, which is going to be the same thing. So for the production, and I'm going to set this for all the pipes. By the way, you can also set this one by one. Temperature, sir. And let's say we are trying to do a weather, by the way. So we can run this. You can say that, you can see that this is evaluated, by the way. So let's check. There we go. Now you can see the temperature of the surrounding is 80. Let's check the other pipelines. Those are 80. Those are 80. Those are 80. Now, did you see what happened is just with one click, I have updated more than, let's see how many pipes we have because I did not check how many pipes we have. So let's check the count of the pipes by passing those pipes. There we go. We have 21 pipelines and they were just updated like in 10 seconds. Let's do one more thing, or let's do one more example before we move forward. Okay. Each well usually is, if I'm doing this correctly, usually our fields or reservoirs, they are basically irregular in shape. They look like this. Okay, so basically the let's say the depth and the contact the surrounding are more prone to having the water problem. So what we usually do is whenever we get like more updated data regarding the gas in happens usually in the field. So once these things happen, there will be a change in the reservoir pressure. So what usually we need to do is we need to update those models for the reservoir pressure to be updated on the thing. So what we usually do is if we double click on any given well, just take a look at this window. So just take a look at the possible options that we can alter in this window. And you'll find that there are lots of things that usually change with time. For example, the productivity index might change, the reservoir pressure might change. By the way, the temperature is not going to change usually unless you have some thermal action happening. The gravity might change in the future. The gas gravity also, the GOR and the water cut are things that are more prone to change. Okay, so let's do one simple calculation. So I'll show you how to automate this. Okay, so if we do something like water cut equals to, let's get the water cuts for all the wells. So let's do this and let's do well. So let's get the all the wells and let's try to get the water cut from the fluid. So let's try to get that. So and once we run this, let's print this out. So print water cut. Okay, so let's run this out. There we go. Now these are all the water cuts we have. We have 47, 47, 47, and whatnot. So let me show you, if we print this alongside with the well name, let me show you how this is going to look like. Let me show you a basic plot of this. So if we import a plotting library, I can also do some data science on top of this gap and basically do some analysis as well. So if we do a bar plot, and on the x-axis, if we set the well names for the wells, and on the y-axis, I'm going to set the water cut. This should basically show me a plot, by the way. There we go. Now this is the basic water cut plot for all of these wells. And we have, I think, something close to 15 or 16 wells. But you can have like more wells than this. You can have like really large number of wells. This is regarding the water cut. You can do the same exact thing for the gas oil ratio. So let me show you. So let's get the gas oil ratio. And instead of doing a bar chart, what I'm going to do is I am going to do a line chart for these, okay, for the gas oil ratio and the water cut at the same time. So let's run this. There we go. Now this is the water cut and the gas oil ratio at the same time. Of course, if those scales are not compatible, you can also activate the log scale. So this is going to be a more compatible thing. So let's run this. There we go. Now this is both on log scale and they are both better visible now. So these are all pulled directly from the gap. So let me show you how we can update those water cuts interactively. So let's assume that the water cut has been rising 5% for each well, 5% for each well. So how can we do this? So this is going to be a very simple equation. We will say we are basically going to iterate through all the wells in the count of wells we have. So we will iterate through those wells one by one, and we will say that we need to get the old water cut. So old water cut equals to, so the water cut of that particular well. And now what I'm going to do is I will multiply the old water cut, or let's calculate a new water cut from this. And let's say old water cut equals to, by the way, you can also make this a little bit faster calculation. I am just showing you in terms of step because I can have like everything in a single line. But what I'm going to do is I'm just showing you how these things can be broken down as per task. So let's say that the old water cut is increasing by the factor of 5%. So once we have this new value, what we can do is we will get those water cut command. So let's get the water cut command. Okay, so let's paste it. And we will update it by the new water cut. We will pass in the new water cut and make sure that you're setting the property. You're not getting it. So let's run this, by the way. Once we push run, there we go. Now you can see 16 values have been pushed in a single click on the server. Okay, so if the values were like 47, or let's say that the old water cuts were 47, so 47 point 1026 multiplied by 1.05. So this should yield water cuts of 49 and a half percent for those newly updated values. So if we double click on these, you can see, let's say some of the wells that have like high water cut, because not all the wells have same water cut. So let's see. You can see that like most the water cuts are already updated, because previously some water cuts basically they were like 16% or 16% water cut, but some of the wells now are 17.7. So this means that those water cuts have been successfully updated. Okay, so this is just one example on how we can update multiple values at the same time. Same thing goes for the gas oil ratio. What you can do is you can also do the same thing for the let's say for uh, for the reservoir pressure. So we can do res pressure. We can update the reservoir pressure by getting the old value of the reservoir pressure. For example, let's or the values for the reservoir pressure is like 3000 now. We can make this, for example, 2555. So we can make this a very, let's say, known value, so we can target this easily. What you can do is if we run this properly, we should get all the reservoir pressures updated. So if we double click on any of these wells, you can see now suddenly the reservoir pressure is also updated on all of these wells. You can also do other commands, like you can automate the simulation. You can get more graphs. You can get statistical analysis from this. You can try a Monte Carlo simulation on top of these types of models. You can do lots and lots of things. This is just a brief introduction on how to connect these types of stuff. So this was the first example. Meanwhile, if you have like any question on the things that was introduced so far, please let me know in the chat box. So once that's out of the way, now it's time to start with the next example. So Mr. Nikhil, please open up the chat box for the people to ask technical questions. Please, technical questions only. So what we're going to do now is we're going to create a application that can basically fit our production data and create some potential forecast with it. Okay, so this is going to be a very interactive application. So I'm going to show you how this is going to work. So let's see if the application is running. So let's run this. Okay, so this is the application is already there. So let's just make everything side by side so you can see what's happening as we move along. Mr. Nasser is asking, can we combine it with Compass and WellPlan? I think Halliburton is already providing APIs for Python, and I don't see why you cannot if they are doing that. So how did I integrate Python with the Gap? By using the Open Server API. That was how. Anyway, let's move forward. So in this example, I'm going to show you how we can build an application that's interactive. We can select wells and we can forecast any part of the well we want, like any part of the history of the well. So this is going to be a highly interactive application. So first of all, we need to get the data. So I am going to get the data from the utility. So get data. Okay, so once we get the data, we can save this application. There we go. Now we can start seeing the wells are showing up. So we can select any well we want, and selecting the wells, it's create a filter for us, by the way. The next step would be is to create a chart that basically shows up on this part of the settings, where we will select the chart and basically we will create a regression based on our selection, not on the full data, but on the selected part of the data. Okay, so let's create a figure. So a figure with the Plotly Express dot scatter. So we're going to create a scatter chart, by the way. Okay, so we will pass the table and make sure that the x-axis is the elapsed production days, because this is a regression problem. Usually the dates are not very welcome, but you can also use the dates. And for the y-axis, I am going to utilize the water-oil ratio for this. Okay, so I'm going to display this on the screen. So let's do a simple display on the screen. So save it. There we go. Now you can see now the history is now starting to show on the settings. Okay, so once you select different wells, you will see like different plots show up in the settings. So the main idea is to select any portion of this well and basically generate a forecast based on that selection, because we don't, to be honest, we don't care about the full history, because the change for this particular example, the change in the trend is basically is there in oil and gas industry, so the trend changes with time. So the thing that we're interested in is the linear portion of this, because this is a linear regression or linear data fitting. So this is what we're trying to do, is to fit a linear line. So basically, we generate and extend a forecast for it. We will make sure that we're basically we are allowing the user to select. Okay, so once you allow the user to select anything, you will see that you will have new options. You can select like any portion of this data. So once this portion of the data is selected, what we can do is we can generate a new table around this selection. So we will say that the elapsed days as in selection. So we would have also we would need to have whatever the things we have selected. So let's make sure that we are saving the selection. So selection equals to this chart. So no matter what you select, it will show up on the screen, okay, as a table. So we will say that selection equals to utility dot get selection. So because we have selections, we can get. And once we get those selections, we can filter those, and we can basically get a smaller version of that table for only select data. So if we output a table to the screen for our selection only, we can get basically a selection only of our data. So let me show you. This is what the table looks like. And these tables actually represent the full data that, let me make this wide. Okay, so this is basically representing the full data that was selected. So if I select like other portions of this well, you will get a table that represents those dates. You can also move your selection and basically get a slicer to update those things for you. For example, maybe if you're interested on the 5 or 6 last points, you can also do that. And you can see how interactive this is. Now, once you have this selection, what we can do is we can actually create a forecast based on this. So let me show you how a forecast can be generated. By the way, this is going to be a very simple approach. You can make this as complex as you want, by the way. So let's do a forecast now. A forecast, before we go ahead and do any forecast, let's make sure that the data does not contain any empty values. So that's why we are replacing everything. with 0. By the way, you can also you can have your own logic for this, but this is going to be the simplest of all. Okay, so what we're going to do is we're going to create a figure that basically displays on the screen, and this is going to be for the forecasted data. So we are going to use scatter for this as well, and this is going to be for the short data. This is the filtered one, and the x-axis is going to be for the times elapsed, and y-axis is going to be for the water oil ratio, and we will display this on the screen. So far, we have not done any regression. We are just making sure that the selection is displaying on the screen, by the way. So for this, we need to do plotly chart display, and we'll say, please display figure 2 for us. You will see that the figure 2 is showing below. So it's actually figure 2, not figures. So let's make sure that. So save it. There we go. Now this is the figure that you see in the middle is basically a reflection on the figure on the right-hand side. So if you change the selection on the right-hand side, the figure on the right-hand side will be updating. So I'm going to use the data on the right-hand side to generate a forecast. So let me show you how we can do this, by the way. So let's generate a forecast. Before we do that, we need a regression. So we need to regress or create a straight line that fits. By the way, you don't have to do a straight line. You can do a polynomial, or you can do exponential. You can do anything you want, by the way, because this is Python. It allows to do lots of things. But for simplicity, we will do a regression. So the values from regression. So utility dot do regression. So let's do a regression. And we need to pass in the x and y. So the x and y will be days elapsed, and the y-axis will be water oil ratio. So once we do this, we will get our regression. Now it's only our task to start adding those regressions as a line chart. So we will say add line. So we're going to add a line to this. So once we add a line, make sure that this is x-axis is set to the same axis before, because these are shared among, and the y-axis is going to also be set to the regression values. And we can also make sure that the color of this regression is red. You can, by the way, you can have like any color you want. So this is add trace. We are missing those. So let's change it. Save it. There we go. Now this is the regression that we have done. So this regression, let's give this a name. So let's give this as linear regressed. Save it. There we go. Now this is the linear regressed data. So if we move the slicer, or let's choose a different way of selecting data. So let's select only this portion of the data. Okay, so once you do this, you will see that there is a linear regression that happens only for this portion of the data. If you want to do the same thing for the earlier data, you can also do that, by the way, but there is no point to do that. Usually we target only the later regions. Once you do this, you can move to other wells. And of course, you can also do the same selection for other wells. For example, let's select these, and you can see how this is going to be regressed. Now, this is just for one parameter, which is going to be the water oil ratio. So let's have a title for this and make sure that the title is visible to the user. Let's call this water oil ratio. Now, this is obvious that this is a water oil ratio regression. What we can do is, since we have everything set up, we can copy the full thing, and then we can just change the parameter. For example, let's change this to oil. So we can also do a regression for the oil, by the way, on the same portion of the data that was selected earlier. So let's do that, by the way, and make sure that everything is reflected once the variable is selected. So let's copy this, make sure that the same thing happens, save it. There we go. And basically there is an error. It says that it does not exist. So I think that I'm mistyping. Yep, I'm mistyping. I'm missing an N. So let's do that. Save it. There we go. Now you have two charts. The top chart is basically representing the water oil ratio regression, and the second chart represents the oil regression. By the way, you can also refine this by moving out some of the points, and you can see once you start moving out those points, you will see that your regression is going to be a little bit better. Of course, you can also zoom on top of these points, so you can basically know which points that you're taking out. that basically resembles the best points that you want to do regress on. Okay, so let's take out these points as well. So by dragging and dropping those polygons. So once you do that, you can see like the regression is basically it's better than before. You can also choose like other wells and do the same steps on top of these wells like this. You will get like generated two regressions, and of course you can get forecasts from these numbers as well. And you can of course copy and paste this chart as many times as you want. And once you copy and paste these charts, what usually will happen? Usually, you can get like many number of variables to be regressed, all of these at the same time. So one final thing, let me show you is actually the regressed values. I will show you next, or sorry, below each parameter that was regressed. I will show you either variables or let's say the calculations. Okay, so if we say that, so st.write, let me show you the full amount of regression. So these days, let me show you the total cumulative production from this regression. So let's save this. There we go. Now for the water oil ratio, we have the cumulative of 34 cumulative values, and we can do the same thing by the way for the oil. We can calculate like how much the oil is yielding from this regression because it has to be very close to the summation of all of these points, by the way. So if we paste this as well, and now you're also going to get how much oil is going to be regressed for these, I think 20 points, we have like 19,000 of produced oil. You can also, by the way, you can also sum the actual amount of oil. So let me show you. So right, let me show you the actual amount of oil. So actual oil. So let me show you how these are going to be calculated. It's very easy. We will do data of oil, and then we will use summation of all of these, save it. There we go. Now you can see the regression has been 19,836 barrels. Um, while the actual is very close, it's actually 1983.6. By the way, if you change the selection, you usually get different results, by the way. But the results are going to be very close. So for example, in this example, you have 24,254 and we have 24,255. So they are basically very close due to this root mean square regression that we've been doing. Thank you so much for joining in, and hopefully you have learned new things and you're interested in the things that we have presented. Meanwhile, please, if you have like